The memory controller handles address translation.
The memory controller handles address translation.
The architecture prioritizes low latency access.
The architecture prioritizes low latency access.
This design increases silicon area.
This design increases silicon area.
The architecture does not scale well.
The architecture does not scale well.
Queue management affects throughput.
Queue management affects throughput.
We're implementing a pipelined architecture.
We're implementing a pipelined architecture.
The bus width impacts bandwidth capability.
The bus width impacts bandwidth capability.
We need to balance area and performance.
We need to balance area and performance.
The architecture supports multiple channels.
The architecture supports multiple channels.
Die size is constrained by cost targets.
Die size is constrained by cost targets.
We're evaluating different interconnect topologies.
We're evaluating different interconnect topologies.
The data path is optimized for streaming workloads.
The data path is optimized for streaming workloads.
We need to reduce the critical path delay.
We need to reduce the critical path delay.
The architecture includes hardware prefetchers.
The architecture includes hardware prefetchers.
Clock domain crossing requires careful design.
Clock domain crossing requires careful design.
We're implementing a distributed arbitration scheme.
We're implementing a distributed arbitration scheme.
The microarchitecture determines IPC.
The microarchitecture determines IPC.
We need to optimize for power performance area.
We need to optimize for power performance area.
The architecture supports dynamic frequency scaling.
The architecture supports dynamic frequency scaling.
The design includes redundancy for reliability.
The design includes redundancy for reliability.
The controller becomes a bottleneck under load.
The controller becomes a bottleneck under load.
The logic path adds extra latency.
The logic path adds extra latency.
We need to identify performance bottlenecks.
We need to identify performance bottlenecks.
Queue depth limits concurrent operations.
Queue depth limits concurrent operations.
The scheduling algorithm impacts average latency.
The scheduling algorithm impacts average latency.
We're seeing congestion at the interconnect.
We're seeing congestion at the interconnect.
Bandwidth utilization is below theoretical maximum.
Bandwidth utilization is below theoretical maximum.
The arbitration logic introduces latency.
The arbitration logic introduces latency.
We need to profile performance under real workloads.
We need to profile performance under real workloads.
The critical path limits maximum frequency.
The critical path limits maximum frequency.
Pipeline stalls reduce effective throughput.
Pipeline stalls reduce effective throughput.
We're implementing out-of-order execution.
We're implementing out-of-order execution.
Memory access latency dominates execution time.
Memory access latency dominates execution time.
The cache hit rate determines performance.
The cache hit rate determines performance.
We need better prefetching to hide latency.
We need better prefetching to hide latency.
Resource conflicts cause scheduling delays.
Resource conflicts cause scheduling delays.
The performance scales linearly with parallelism.
The performance scales linearly with parallelism.
We're optimizing for tail latency reduction.
We're optimizing for tail latency reduction.
The throughput saturates at high load.
The throughput saturates at high load.
Latency-sensitive operations need priority.
Latency-sensitive operations need priority.
Power consumption rises with parallelism.
Power consumption rises with parallelism.
We're implementing aggressive power gating.
We're implementing aggressive power gating.
Dynamic power dominates at high activity.
Dynamic power dominates at high activity.
The power budget constrains performance.
The power budget constrains performance.
We need to optimize leakage current.
We need to optimize leakage current.
Clock gating reduces dynamic power significantly.
Clock gating reduces dynamic power significantly.
The power delivery network must handle peak current.
The power delivery network must handle peak current.
We're using multiple voltage domains.
We're using multiple voltage domains.
The design targets 2W power envelope.
The design targets 2W power envelope.
Power efficiency is critical for mobile devices.
Power efficiency is critical for mobile devices.
We need to balance performance and power.
We need to balance performance and power.
The idle power must be minimized.
The idle power must be minimized.
We're implementing adaptive voltage scaling.
We're implementing adaptive voltage scaling.
Power analysis shows hotspots in specific blocks.
Power analysis shows hotspots in specific blocks.
The efficiency metric is performance per watt.
The efficiency metric is performance per watt.
ECC corrects bit errors at the hardware level.
ECC corrects bit errors at the hardware level.
Error handling logic needs refinement.
Error handling logic needs refinement.
We're implementing end-to-end data protection.
We're implementing end-to-end data protection.
The retry mechanism handles transient errors.
The retry mechanism handles transient errors.
Parity checking detects transmission errors.
Parity checking detects transmission errors.
We need graceful degradation on component failure.
We need graceful degradation on component failure.
The error logging captures fault information.
The error logging captures fault information.
CRC verification ensures data integrity.
CRC verification ensures data integrity.
We're adding redundancy for critical paths.
We're adding redundancy for critical paths.
Error injection testing validates robustness.
Error injection testing validates robustness.
The fault tolerance mechanism adds overhead.
The fault tolerance mechanism adds overhead.
We need to handle both soft and hard errors.
We need to handle both soft and hard errors.
The error reporting is sent to firmware.
The error reporting is sent to firmware.
We're implementing scrubbing for latent errors.
We're implementing scrubbing for latent errors.
The reliability target is 10 years MTTF.
The reliability target is 10 years MTTF.
Firmware optimization reduced write amplification.
Firmware optimization reduced write amplification.
The firmware update improved stability.
The firmware update improved stability.
We're exposing new features through the API.
We're exposing new features through the API.
The driver needs optimization for this hardware.
The driver needs optimization for this hardware.
We need better documentation for the interface.
We need better documentation for the interface.
The firmware manages wear leveling.
The firmware manages wear leveling.
Command queue depth is configurable in software.
Command queue depth is configurable in software.
We're implementing a backward compatible interface.
We're implementing a backward compatible interface.
The software stack adds latency overhead.
The software stack adds latency overhead.
Firmware version 2.3 fixes the bug.
Firmware version 2.3 fixes the bug.
We need to update the register specification.
We need to update the register specification.
The boot sequence was optimized.
The boot sequence was optimized.
We're implementing runtime configuration.
We're implementing runtime configuration.
The firmware handles exception conditions.
The firmware handles exception conditions.
The API supports asynchronous operations.
The API supports asynchronous operations.
This feature complicates validation.
This feature complicates validation.
The controller behavior is workload dependent.
The controller behavior is workload dependent.
We need comprehensive corner case testing.
We need comprehensive corner case testing.
The simulation time is too long for full coverage.
The simulation time is too long for full coverage.
We're using formal verification for critical logic.
We're using formal verification for critical logic.
The test bench found a subtle race condition.
The test bench found a subtle race condition.
We need better observability for debug.
We need better observability for debug.
Assertion-based verification caught the bug early.
Assertion-based verification caught the bug early.
The validation plan covers functional and performance.
The validation plan covers functional and performance.
We're implementing hardware assertions.
We're implementing hardware assertions.
The debug interface provides cycle-accurate traces.
The debug interface provides cycle-accurate traces.
Code coverage metrics show 95% achieved.
Code coverage metrics show 95% achieved.
We need to reproduce the silicon issue in simulation.
We need to reproduce the silicon issue in simulation.
The emulation platform enables software development.
The emulation platform enables software development.
Post-silicon validation revealed timing issues.
Post-silicon validation revealed timing issues.